Sir, why do we need the context diagram first of all? What exactly that I will understand with the help of the context diagram? It will just give you the structure information, but it fails to give you the behavioral information. First of all, the first one that I have is customer. The second one that I have is transaction. The third one that I have is terminal. And the fourth one that I have is account. How we have divided the data flow diagram, so even the finite state machine diagram also we can divide. Basically to understand the flow of data, okay, from one process to another process or one part to another part. Hello everybody, I welcome all of you to the next session of levels of testing. So guys, what is that I have in the today's session? Let me show you that. So guys, I have the context diagram of SATM. So why do we use this context diagram? So why are we studying different types of diagrams and levels of testing? Yes, I'll come to that point. So firstly, I will be starting with the context diagram, then followed by I will be discussing the data flow diagram of SATM, and then after that I will be discussing the ER diagram. So today is full of diagrams with all respect to SATM. Alright, so guys, without wasting much of your time, let me get into the session how exactly these diagrams are working. So instead of understanding how exactly these diagrams are working, let's understand how exactly SATM is being represented with the help of these diagrams. Yes, the first one that I have is context diagram of SATM. So you all know that SATM in the sense like, how exactly my ATM machine is working. So that functionality I'm going to depict with the context diagram. Sir, why do we need the context diagram first of all? What exactly that I will understand with the help of the context diagram? So you will have this question. Yes, my dear students, listen to me carefully. The context diagram will help me to understand the boundary of the system. So who is inside the system and who is outside the system? So which are all the external body which is connecting with this system, and what is the internal bodies that I have in my system? So to create a boundary, so I use the context diagram. So it creates a context or it creates a boundary around the system. That's what you need to understand with respect to this diagram. So fine, then what is that I have here? Please observe. I have the terminal keys. So you will be having the keystrokes. So guys, in the ATM machines, you have seen the terminal keys, right? So fine. So with that terminal keys, you will be getting the strokes. So that is going to the simple ATM system. So fine, whatever the strokes that you are giving, so it is going to your system. So that's what you need to remember. So fine. Then after that, what is that you have? So you have the screen. Please understand. So you have the screen. The information from the system is going to your screen. So yes, I understood that. So I'm getting the strokes from the keyboard, and then the information from the system is going to the screen. That's what you need to understand. Then after that, so please observe. So from the terminal slots, okay, so please understand, slot status is coming to the ATM machine. All right, slot status is coming to the ATM machine system. That's what you need to observe here. Then from this, slot command is going to the terminal slots. All right, so fine, slot in the sense where you insert the card. That's what you need to understand it as a slots. So fine, that we understood, sir. Then what is this? So this is all about the door. ATM machine has got the doors, right? So fine, even the door status is also getting interacted with the machine. So that's what you need to understand. So machine in the sense simple ATM system. So I have the system. So with this system, so these doors are getting communicated. So open the door and close the door. Kulja sim sim. Okay, that's what you need to understand. So here you will be able to see the communication. So the communication is going to the door to open the door to give the cash and close it once it is done. So this is how the communication is happening. That's what you need to notice. All right. So then observe here. So guys, whenever you enter the permanent account number, all right. So that communication is going to the central bank, okay, from your ATM machine, and the information is getting exchanged here. That's what you need to understand. Whenever I type whenever I insert a card, so it will ask me to enter the PIN. So it is getting cross-verified. All your data is not stored in that ATM machine. That's what you need to notice here. So that data is getting verified with the central bank. Okay, so that's what you need to understand. And then you have to provide the PIN. So if it is matching, only then the process will continue. So this is what you need to understand. This is the bodies that you need to understand, which interacts with the system. This is how we create the boundary to the SATM system. All right, so what is the next diagram that I have? So next diagram that I have is a data flow diagram. Basically, to understand the flow of data, okay, from one process to another process, or one part to another part, so one task to another task. So we are trying to implement the diagram called data flow diagram. The name itself says that it helps you to understand the flow of the data. Yes, let's understand. It's very simple that if you understand, you all know how exactly ATM machines are working. So you just have to compare that with this diagram. That's it. So it's very simple to remember. So please understand this. Guys, this is a terminal slot that I have. So this is a device sense and control. Okay, this is what you need to understand. So this is a device sense and control. So what happens here? So the command goes to the terminal with respect to the slot. So from this system, so command is going to the terminal slot. This is how the data is traveling here. So fine. Then after that, from the slot, the slot status is getting updated to the system, that is device sense and control. So that's what you need to understand. You need to observe, you need to think about the data, how exactly it is traveling. So from here, the data is going to the terminal status, terminal slot. From the terminal slot, the data is coming to the device sense and control. That's what you need to observe here. Then after that, next I have, what is the next one that I have? Terminal doors. So need to understand. So door status is coming to the device sense and control. Okay, there is a module called device sense and control. So you need to observe here, this is a terminal slot. Okay, so this is a terminals of doors. So I will be getting the status of both doors as well as slots. All right, so in the same way, so guys, so I'm just giving the status of the door, whether it is open or closed. Then after that, I will get the command from the system to the door. Should I open it or close it? So the data is coming from here to here. But here, data is going from here to here. You need to observe how exactly data is getting transmitted. So fine, moving forward. So in the same way, I have the central bank communication. This is one system that I have. So guys, here what is that I have? Permanent account number is going to central bank. My permanent account number is going to the central bank. And then, so from here, from the central bank is expecting the PIN that you wanted to enter. So it is asking for you to enter the PIN. So that's what you need to understand. So fine, what is that? It is happening. So expected PIN. So I am creating the session. I'm trying to manage the session. So please observe how exactly this is interlinked. Whenever I'm entering the PIN, so even I should enter the PIN within the given time. That's what you need to understand. So that is what I'm calling it as a managed session. So fine. So I'm entering the PIN. Please understand, account information is required from this session. It is asking me to give me the account information. Yes. So for that, I will establish the session. So that's what the request is coming from the managed session. So the data is coming from here to here. So fine. After this, what? So let's understand this. So please observe this. Whatever the device commands that I have, device commands in the device status. So this is again related to the session. Whenever you are using the slot, okay, I cannot keep my card inside the slot for how long ever I want. So till my session is on, I can only keep that. Even in the same way, the doors of the cash tray will be open for a particular period of time. So that will be managed by the session. The data is communicated between this. That's what you need to understand. So all these things, what is that you need to understand? How exactly the data is traveling from one module to another module. The flow of data is what you need to understand. This is very simple to remember. Sir, yes, we understood what is context diagram, what is data flow diagram. Yes, we also have one more diagram, that is ER diagram. So in this ER diagram, you all know that ER diagram in the sense entity relationship diagram. What exactly this diagram is doing? So this diagram will help me to identify the different entities that I have in my system. So along with that, it will also tell me how exactly each entity is related to other entity in the system. So that's what you need to understand, the entity relationship diagram. So now I have identified 4 different entities in this diagram. The first entity that I have here is the customer. So what is an entity? Any physical objects, any real world object, that is what I will call it as an entity. So which has got the properties. So fine, like that in the SATM system, I have identified, so we have identified 4 different entities which is depicting in the diagram. So the first entity that I have is customers. So this is the name of the entity and this is the properties or the attributes of the entity. That's what you need to understand here. So how many entities we have? First of all, the first one that I have is customer. The second one that I have is transaction. The third one that I have is terminal. And the fourth one that I have is account. This is the 4 different entities that I have in my system. Let's check that. So what exactly the diagram is going to speak about? My dear students, when I have the entity of customer, so customer entity is related to the transaction. Yes, yes. So customer entity is related to the transaction entity. So please understand. So I have here 1 and I have 0 to n. What exactly this is all about? This is what I will call it as a cardinality ratio. What exactly cardinality ratio in the sense? So one customer can have 0 to n number of accounts. Is it? No. Transactions. Please observe here the entity name. One customer can create or can perform 0 to n number of transactions. That is what we are trying to depict here. Remember. And the same way, one transaction or n number of transactions will have one terminal. Or either the way, one terminal will have n number of transactions or 1 to n transactions. That's what you need to remember. To be very frank and to make it very simple, let me give you an example. My dear students, one teacher can teach many students. So here teacher and the students are the different entities. Teaching is the relationship that I have. In the same way, so I have transactions and I have terminal. So please remember, one terminal can perform 1 to n transactions. That's what they have depicted here. So occurs is a relationship. So let me tell you again. So one terminal occurs in 1 to n number of transactions. I can also have one transaction or I can also have n number of transactions. That's what you need to remember here. In the same way here, one customer can have the session 0 to 1 transaction. That's what you need to remember. In one session, I can have 0 to n transactions. So that is what you need to remember in this diagram. In the same way, so please remember this. This is very simple. You will only tell me. Okay? If you just look at the diagram. So I have customer and I have account. So what is the relationship that you have? Has. So what will happen now? One customer has got one account. In the same way, n number of customers can have n number of account. N number of customers has n accounts. That's what you need to remember. So this is what you will be able to understand with the help of ER diagram. Yes, sir, we have discussed the context diagram. We have discussed the data flow diagram, which will help us to understand how exactly data is flowing, which will also help us to discuss ER diagram to understand the relationship between different entities. Now, guys, it's time for us to understand why do we need this? Why do we need these diagrams? Basically, these diagrams discuss about the structure. That's what they say. Please observe here, data flow diagram and the ER diagram contains the information that is primarily It'll just give you the structure information, but it fails to give you the behavior information. But my point of view of understanding these diagrams is mainly for testing. But as a tester, so I will be in a problem situation, guys, because I'm mainly concentrating on the behavior because I need to write the test cases. So in this point of time, so I will be going to the diagram called finite state diagram. So which will help me to understand both structure as well as the behavior. It's going to be one of the best diagram for a tester to understand the behavior as well as the structure. So then what exactly that I have with respect to the finite state diagram? So guys, I will be speaking about the finite state diagram in detail in the coming slides with respect to one of the functionality of SATM. So which will help me to understand the system. So how exactly the system is getting decomposed and how exactly it is behaving along with its structure. So let's understand that. So we also use the finite state machine. So that's what I have told you. So we will be understanding the finite state machine diagram. So which will help me to control the modules, represents the point at which structure and behavior interconnect. So it'll just give me the information about the structure as well as the behavior. So finite state machine is going to be the savior to understand both structure as well as the behavior. Yes, we will be understanding that. The upper level finite state machine divides the system into the states that corresponds to the stages of customer usage. Yes, I will be discussing that. What exactly that point is telling all of you is, we will be having the finite state machine in two different levels. One is high level, another one is low level. When it comes to the high level, whenever I utter high level, you need to understand the information is very less. So you will not have a detailed information. So you will not have the decomposed information there. So that's what you need to understand. We can also decompose the finite state machine diagram to understand the behavior in detail. That's what we are going to discuss that. So finite state machine can be hierarchically decomposed. That's what they are saying now. Finite state machine can be divided into hierarchically. So we can decompose that hierarchically in a much same way as data flow diagram can. How we have divided the data flow diagram, so even the finite state machine diagram also we can divide. So we can divide from high level to low level. That's what we are trying to say. So divide in the sense what? Decompose. So I will speak about this point in the coming slides in detail with the diagram. So please remember this, write down this point. All right. So fine. State transitions are caused. Please remember, state transitions are caused. I am in one state now, so I am moving to another state. Right now, I'm teaching now. So after this teaching, I will just go out and I have a coffee. This is state transition, moving from one state to another state. So this is what we call it as a state transition. So in SATM, how exactly the state transition is happening? So right now, I am in the entry of the pin code. So from that, I will go to the account selections, which type of account that you need to select. So that is what I will call it as a state transition. How exactly it happens? So please observe here, either by events, any event should happen. You should press next. That is an event which is occurring. So by events at the ATM terminal or by the data condition. Data condition in the sense what? Session might time out, like, so the system is waiting for you to make sure to give some input, but you're not giving, okay? That is one situation. And if you give, something will happen. If you don't give, something will happen. The event will occur. State transition will occur. So because of these two reasons. That's what you need to remember. Fine. Moving forward to the next point. When this transition occurs, corresponding to action may occur. Transition, if the transition occur, so related to that, some action will happen. Yes. So that's what you need to remember. We chose to use the screen display as an action. We chose the screen display as action. That's what you need to remember. And this action will prove to be very handy when we develop the system level testing. So whenever we are doing the system level testing, so we take the screen. So to understand the state transition, that's what you need to remember. The function, data, control models. Please remember these points. Function, in the sense what exactly it is behaving. Okay, so data and control models are basis of design activities in the waterfall model. All these things, these 3 points are the design activities. So you remember, right? Waterfall model, the first one is a requirement, second one is a design, and the third one is a coding. So all these things will come under the design activities in the waterfall model. So that's what you need to remember here. So fine. So guys, hope you understood why do we have this finite state machine. What is the advantage that we have with respect to the finite state machine? So it gives me, I repeat one more time, it gives me both structural and behavioral information of our system. So that's the advantage that we have. Let's check for an example. Here I have an example for all of you. This is a beautiful structural and behavioral finite state machine. Here I'm presenting to all of you. So imagine my system is in the idle state now. Okay, my system is in the idle state now. So from the idle state, it can go back to the idle state. That's what you need to understand. So bad card. Okay, if you enter the bad card. So instead of inserting the ATM card, if you put the PAN card or the visiting card, so the system will go back to the idle state. That's what you need to remember. So fine. Then suppose, imagine you have put the proper card. So card is okay. So then it is waiting for the pin. So it is waiting for the pin. Suppose cancel or pin failed. You have not entered the pin. Oh, nane enter madle pin anta neevu nintkonಡ್ರೆ. So it will go back to the ideal state again. So suppose if the pin okay, so it will go to the next state, that is waiting for the transaction selection. It is waiting for the transaction selection. Avaglu neevu transaction select madala. So it will go back to the ideal state. Okay. So fine. Suppose ಯಾವ transactions, which are all the transactions that I have? So please understand, I have B1, B2, B3. B1 is a deposit, B3 is going to be balance, B2 is a withdrawal. So this is the 3 different branches that I have. All right. So you will select any one of these. Suppose if you do not select, so again it will go back to the ideal state. Suppose if you select any one of these, so it will go back to the closed session. So from this again it will go back to the ideal state. So this will give me both structural as well as behavioral information of the system. All right. So guys, now I have shown you this. Let me decompose this. Okay. Let me give you in detail. Okay. In this next diagram. So please observe here. Right. So I have the ideal state, right? So in this ideal state, again, I'm going back to the ideal state. So wrong card or display screen, eject card. So wrong card, visiting card. So at that time, it will go back to the ideal state. So fine. After that, suppose imagine the card is okay. So waiting for the first pin entry. You enter madala. Again, so it is waiting for the second time pin entry. Aglo madala. So it is waiting for the third pin entry. This detail you did not had here. So what is that I'm doing here? I'm decomposing and I'm giving you more detail. Where, so please observe, in this step, I'm giving you more detail. This is what I'm calling it as a decompose. Compose ಆಗ್ಬಿಟ್ಟಿದೆ. So ಅದನ್ನ decompose ಮಾಡಿ detail ಆಗಿ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. So that is the advantage that you have with a finite state machine. So in the same way, so guys, if the pin is correct, so it is going for the next state. So please understand here, wait for the transaction to choose. That's what you need to understand with this finite state machine diagram. All right. So guys, so you have understood the finite state diagram. So I have functional decomposition of SATM system. What exactly decomposition is all about? If you ask me, I will give you an example. It's a hierarchical decomposition. That's what I've told you in my previous slide. Hope you remember this. Hierarchical decomposition. So top-down approach. Right? So remember this. So this is my ATM system. SATM and the bejaragbittidappa. ATM system and the listen to me. So ATM system, SATM system has got 4 main modules of the functionality. The first one that I have is device sense and control, so which is one of the modules that I have. The second one is central bank communication. Third one I have is terminal sense and control. The fourth one that I have is manage sessions. So each module has getting decomposed So next level there. So when it comes to the device sense and control, so please understand it is getting decomposed. Door sense and control. Other bare model. Other next to slot sense and control. So I have two subsystems inside this subsystem. Alright, that's what you need to remember. And then I don't have any subsystem in the central bank communication. But when it comes to the terminal sense and control, one is key sensor, another one is screen door. One is key sensor, another one is screen driver. That's what you need to observe here. Alright, so fine. When I come to this manage session, please understand. When I come to this manage session, our manage session detail like divide madbitidini. So task wise. So please observe here. Validate card. One functionality. Manage session olagade irodu. Next, validate pin. Adro olagade get digit. So when it comes to manage transaction, close session. So all these things are coming inside the manage session. So this is what I will call it as a decompose. So idanella tegdu idrolagade hakadana compose anta karitini. The reverse way is what I will call it as decompose. This is what you need to understand with respect to the functional decomposition of SATM system. Moving forward to the next topic. Guys, topic olagade subtopics irutalva. Simple agi helbiಡ್ತೀನಿ. That is what I will call it as a decomposition. Imagine I have the first topic, that is SATM system. Adru olagade 1.1 device sense and control. So that's what I have here. 1.1 device sense and control. So idru olagade nange subtopics ide. So that is what I have written it as 1.1.1. So get door state. Okay. Next 1.1.12 control door. So that's what you need to understand. The next one that I have is 1.1.3. So dispense cache. So subtopic olagade subtopic. So that's what I will call it as a functional decomposition. So using this diagram, we have written this. All right, that's what you need to understand. So let me give you one example. One andre yadu. So one andre this SATM system. Okay. So next 1.1 andre yadu. Please remember 1.1 is what? So please understand. Device sense and control is 1.1. So let me write it here. 1.1. Let me help you to track 1 so that rest of the things you can track it easily. Next one. So please observe here. 1.1.1. So what is that? So door sense and control. Please observe here. Door sense and control 1.1.1. All right. So fine. Going back. What is this 1.1.1 get door status? Please observe here. Here I have get door status. Okay, imagine get door status. So this is what I will call it as a 1.1.1.1. So hope you understood. Okay, so this is how I have given the decomposition of the entire SATM system. Guys, with this, I have come to a conclusion of this session. So hope you have learned the different diagrams that I have. So what is the context diagram is doing? What is the ER diagram is doing? What is data flow diagram is doing? So will I use it? So it is not helpful for me to perform testing. So for that reason, I am going for finite state machine diagram, which will help me to understand both structure as well as behavior of the system. So along with that, I will also learn the functional decomposition. So dividing hierarchically one topic into subtopics till the end. So that's what I will call it as a functional decomposition. By saying this, thank you. Bye-bye.